Hi everyone, welcome to this new episode of Gary Mosher, aka Draft Science, making a fool of himself in front of the entire web. Last time we let nature prove that 4 times the energy resulted in only twice the velocity. And Gary's response was that it doesn't prove anything. In other words, he's claiming that nature can't be trusted. Nature is lying. And then Gary came up with a new law. We all know about Newton's second law. Force is equal to the time derivative of the momentum. In other words, force is directly proportional to the acceleration. But no, for Gary, force is directly proportional to the velocity, not the acceleration. Twice the force, twice the velocity. I am not kidding, it's really what the old crackpot said. Listen to him.
Twice the force, twice the velocity. Not 4, no 4s anywhere there. 3 times, no 9s anywhere.
Alright, let's put that on the test bench. We'll see what nature says. So we're going to use again a glider on a level air track, and we're going to apply a force to it and measure the resulting velocity. Then we are going to double the force and see whether velocity is doubled or not. So I have here 2 identical rubber bands and a holder. Let me install one of them. We can use this single rubber band to catapult the glider, like this. Very simple. Okay, so here a trigger has been set up so that the computer will start recording as soon as the glider is 20 centimeters away from the motion detector. And very important, I arbitrarily place the edge of the glider on the 195 centimeter mark. Ready? Go. See how the computer automatically started recording the motion. Alright, the data are saved. Now let me install the second rubber band. Done. Now I don't want to overwrite the data, so let me open another file. We can clear the old data it contains. And I'm going to launch again the glider by placing the edge at the same position as before. So that's twice the force. Let me set up the trigger. Okay, the computer is waiting for me to release the glider. Ready? Go! And again the computer automatically started collecting the data. And here we can see on the curve that the glider came out of the motion detector's field before the end of the data collection, which is normal since it is obviously moving faster. Alright, let's look at the data. I'm going to reopen the file that corresponds to a single rubber band. We are interested here only by the lower graph, which represents the velocity as a function of time. And the first thing I want to point at is that we can clearly see that the glider's velocity is constant once it has been launched, which confirms that friction is negligible. So, no, Gary, you cannot invoke friction to explain why the experiment is going to prove you wrong. Also, the mass of the rubber band is ridiculously small compared to that of the glider, so you cannot claim that there is some residual energy in the vibration of the rubber band. So, let us select the region where the velocity is constant so that we can extract the mean value. 0.1406 meters per second. Now let's open the second file. Once again, it is clear that friction is negligible since the velocity of the glider is constant after it has been launched. Let me select the region where the detector could still see the glider and extract the mean value. 0.1957 meters per second. Alright Gary, here's nature's answer. The ratio of the velocity with 2 rubber bands to the velocity with 1 rubber band is nearly square root of 2, as predicted by the work energy theorem. Twice the force, only square root of 2 times the velocity. Keep trying.